This is problem 7 from chapter 15. Crates A and B weigh 100 pounds and 50 pounds respectively. If they start from rest, determine their speed when t is equal to 5 seconds. Also find the force exerted by crate A on crate B during the motion. The coefficient of kinetic friction between the crates and the ground is 0.25, and we have a 50-pound force acting on crate A. So first, let's draw a picture and put down what we know. This is problem 7 from chapter 15. We have crate A, we have crate B, we have the 50-pound force acting on crate A. The mass of, or not the mass times G of crate A is 100 pounds. The mass of crate B times G is 50 pounds. The coefficient of kinetic friction is 0.25. We want to find V at t is equal to 5 seconds, and also find the force that exerted by crate A on crate B. And we are assuming they are starting from rest. So let's say V1 is equal to 0. This is chapter 15, so we should be using the impulse-momentum relationship, which is equation 15.3. This is the initial momentum plus the impulse is equal to the final momentum. This is a vector equation. We can use it in this problem just for the x components, since we're only looking at the horizontal motion here. They write this as the sum of the integral that we have here, or instead you could just say that sum would give you the net force, and this is equal to mv2. I would write this instead as F net. This is the net force acting on your system. That gives you the impulse. Okay, so our system here is, I'm going to say, is crate A and crate B. If we choose this to be the system, this is the net force acting on the system. Acting on the system, we have this 50-pound force, and we have the force of kinetic friction. These forces are not changing in time, so they can come outside the integral here. So this would be F net, and then we would just have the integral of dt, which would just give us the change in time. This is F net times delta t. We have mv1 here, but the crates are starting from rest. So we have 0 plus F net times delta t is equal to mv2, and we can just look in the x direction and make that the x component of the velocity. We're looking for the velocity at 5 seconds, so we can say delta t is equal to 5 seconds, and my net force would be the 50-pound force minus the force of kinetic friction. So that'd be 50 pounds minus FKF times delta t, which is 5, is equal to the mass. This mass is the mass of the whole system. The system is crate A and crate B, so the mass would be 150 pounds divided by G, which is 32.2, times V2x, which is what we are looking for. So in order to finish this, I need to find the force of kinetic friction. If I look in the vertical direction, the only forces I have in the vertical direction are the normal force acting upwards and the force of gravity acting downwards. So the normal force is equal to the force of gravity. This is the force of gravity for the entire system, which would be crate A and crate B. That would be 150 pounds. So times the coefficient of kinetic friction. So this would be 50 minus the force of kinetic friction. That's our net force, times delta T is equal to 150 divided by 32.2 times V2x. We can use this and solve for V2x, and we get 13.416 feet per second for the speed at 5 seconds. They also asked us to find the force that A exerts on B. To find the force that A exerts on B, I'm going to have to pick a different system. So in this case, I could say either make my system just crate A or just crate B. And I'm going to choose to look at crate B. If I do this, crate B instead of crate A, then I don't have this 50-pound force here to worry about, so that makes it a little easier. This is my system, the force of kinetic friction acting on my system, and I also have the force that A exerts on B, which is what I am looking for. I can again use the impulse momentum relationship. My initial velocity is still 0, so this is 0 plus the integral of the net force with respect to t. Both these forces are constant, so you can pull them outside the integral, and you have the force that A exerts on B minus the force of kinetic friction. Again, the only forces that you have in the vertical direction are the normal force and the force of gravity, so the normal force is equal to the force of gravity in this case. The force of gravity, this is just for block B, is 50 pounds, so this is 0.25 times 50. That's the net force times delta T, which is still 5 seconds, is equal to the mass of the system. The system is just crate B. The mass is 50 divided by G, which is 32.2, times V2. Oh, well, we found what that is here, so now we can put this in, and then we can solve for FAB. I will leave the math for you to work out on your own, and you should get the force that A exerts on B is 16.67 pounds. You could also solve this by, instead of in the first part, instead of looking at the two crates together as our system, we could have done just crate A and then later just crate B. Or you could do the two crates here together as one system, and then instead of crate B here, you could have done crate A. So you have 3 different systems that you can choose, and you only need 2 of the 3 systems in order to solve the problem. And that concludes problem number 7.